Okay, I'm back with part 3. Um, just talked about some software for UML, and let's finish up with class diagrams. So, if you remember at the very beginning, I told you that class diagrams are limited, but they are good for certain things. For example, finding about the data and the attributes, right? It's like a data model, but it's a little bit more than that. Um, it also tells you, like, gives you a quick picture of what's happening in your system, so it's like a good snapshot. By looking at these class diagrams, you can see if you have too many classes, for example, or you don't have enough. You can see if something is too complex, like the relationships are too complex. Maybe you want to merge some classes into one because they are too tight connected to each other, or you don't have enough relationships, so you can separate them more. You can also very easily see dependencies between one class and another. But all of these are very static information, static structural information. So the class diagrams are not so great for algorithmic behavior. That is not data driven, it's control driven. You won't have the flow of steps of objects to solve a problem. There's no control flow, there's no event driven information, or like if it's a web based system, you don't see the requests. So basically there's no sequential or time information in here. So what other diagrams do we have? Let's go from classes of people to individuals, and this lady is really important for that. She's Ayn Rand. If you know about her, she's supported individualism a lot. So I want to emphasize that from classes are general descriptions, and when you make an instance of a class, it's like an individual. An object is an individual. So you can make an object diagram, which is just one instance of that class. Now, what is this good for? Now you can talk about different instances, and if they have some relationships, and you want to talk about that. And the way you do that you give it a name, like Smith, and the type will be the class. Smith is a human being or man, and again the attribute. So you're listing the attributes, but this time you're listing the attributes with actual values because you're talking about an instance, right? And now you have these objects. You can connect them by lines, and you can just put some name in there saying that okay, these two objects are connected because of this or that. For example, you can say a customer that is checking out, like buying something right now, is about to check out, and we need to calculate the price for it. Okay, so that's like one specific customer. You're not talking about the whole class. You're talking about one customer. Let's look at an example, and it will be a little bit clearer, hopefully. This is about a school system where there are some instructors and there are some classes and courses. These are individual instructors, like DB is Vlad Varnica. And it has this guy is the home campus is in Oxford, and instructor Nora Cosentina is from Tunisia. This instructor is teaching this class, UML to Top Gun. We're not talking about Top Gun, but they are. There's this guy is teaching some other class, AZ12. Now this class is actually part of a course called EMF Best Practices, which are again like this is not the class, it's one of the instances of the class for the course. Okay, so this is a good confusion for you. We're talking about classes, and this diagram is also talking about classes, but these are classes that are taught by these instructors. So then this is an object of the class, if I can confuse a little bit more. Anyway, and the course, this course is taught by two instructors. So this course has two classes, this class and this class, and they're taught by these two different instructors. So basically you're making a diagram with instances, and you can put some more information on there about these instances. Now there's time information here, right? Because instances are created over time, and they may have different relationships. So now you're not looking at a static a general structure anymore. You're looking at a lot more details. Since I mentioned time, let's look at a diagram made especially to denote timing information, and that's a sequence diagram. I'm in the UML sequence diagram slide. It's basically an interaction diagram that models a scenario executing in a system. So it's like a user story. You're talking about one story, and you're showing the steps of time, the steps happening in time in your system. And it's said that this diagram is the second most used UML diagram after class diagram. So it's a very important diagram. It's very useful. The key parts of the sequence diagram are the participants and messages. Participants are the objects that act in the diagram. And you start from the left hand side with the message. So messages are communicated between participants, and how like the control is passing between participants, because as a program, you know, we always have one point of control and you're switching between places. That's what we mean by control flow. Like for example, when you start the program, you click start and then it goes to a new interface, so then the control is going from the first interface to the second interface, and so on and so forth. Now the axis in the sequence diagram, there's horizontal and vertical axes. The horizontal axis are the objects, so each object will be in a different horizontal axis, and vertical is showing time. And you'll see that in this example in the next slide. And in this sequence diagram, horizontally we're going through different participants. So the first participant is the customer, which is an outside entity, but the other participants are the different components of the program, like the search page. So this customer is searching something. There's a search page, there's a search results page, there's a catalog and search results actually. So the customer starts with an onSearch function, and on the search page it starts some process in here. It validates the search criteria and within itself, and if it's validated it will do the search. If it doesn't get validated, it will display an error message in the search page. If it's valid, then it will go to the catalog, do a search by author, which will create a search result, and that search result will be displayed on the search results page. So what is in here is very nice, right? You see these different instances, like this is one customer, one search page. It's like an object diagram, but you also see the timing information. You see the different functions that are being called, and when they're calling and when they're returning. So this diagram is very useful, especially when you're doing something very complex and there's the timing information is really critical, so you want to show it. Okay, now talking about these UML diagrams, I'm sure some of you are really bored and saying why do we care about these things, but the point about these diagrams, you don't make diagrams for everything. You only make diagrams when you need them. And as I said, when you have a critical thing you want to explain to your customer or to your teammates, or you want to show it, you want to draw it so that you are very clear about it for yourself. Like sometimes you want to draw a diagram just for yourself, right? When you're like making a storyboard or you're drawing like a sketch of something. So these diagrams are really useful for that. Okay, next slide is let's go break down this diagram and show you the details a bit. These are some conventions that you can follow, but you don't have to follow basically. Those object squares that on the top, you can put the name of the instance, and then the type is like an object diagram basically. So name, type, and here is like anonymous. It doesn't have a name, it's just a type. But it's not the class, right? It's not the class. It's an instance, but it's anonymous. And here this is an instance without any class. It just doesn't exist. These are called lifelines, the dotted lines that you saw. The active object is in this case is bolded with a line. Next slide is the messages, or whichever the horizontal lines. You saw that it's already like a message name and arguments. It's like a function basically. The message name is basically a function, and the arguments are what you're passing. So it's like a function call, and you're calling an object and something in the object. Next slide. Those methods are drawn with can be drawn with different types of lines basically. So this dash line is like flow of control. It's not calling a real function, it's just passing control to this function. But in here it's like it's more about calling functions. So here you can see that a function is called in this controller instance, and it's going to return from here, and within the controller it's going to call another function and it's going to return. So the dash lines will be the returns, okay? And this type of representation with an arrow with a single line is called an asynchronous call, which is a concurrent call, like a parallel call, or you're not waiting for it. It's happening in the background. Next slide is about the lifetimes. Lifetimes can represent a lot of things too. So I didn't show you before, but you can put these boxes. It was in the first example. The boxes represent a process. Okay. And within the process, some different things can happen. So far I showed like diagrams where everything was on the same level, but here you can see that some object is being created at a different level. And if you put a line saying new, you can see that it's creating this object. And whenever it's created, it starts a process, which is denoted with this box. And at the end of it, it will be deleted. It's because that object is going to be deleted, so you're presented by this cross. And when it's deleted, it returns back. So the return is shown with the dashed line. So as you can see, it's very you can represent many different things in these diagrams. So this was a database query. There was a handler, which created a query command, which then in turn creates a database statement, and it executes that statement. The results come back. You can extract results from it with this new process, and then after you're done, you send back a message to the database statement and you close it, which destroys it. Okay. In some languages like C++, you can delete objects, so you know exactly when it's deleted. But in Java, you don't have that, right? You don't have a delete keyword. But do you know when objects are deleted? Actually, yes, because if you have a function and you declare something in a function, and at the end of the function return, and then nobody can access that whatever you declared in the function, then that's going to be definitely deleted. Like if you cannot access something, it's as good as gone. And that's actually the system Java uses. If something is not referenced anymore, then it's going to be deleted by some system called garbage collection. It's basically going around in your program, looks at all the garbage and collects them. If you're not going to use something, it's going to collect it. It's like a server at the restaurant. If you're done with your plate, they're going to take it away. Okay, so next slide. Let's talk about the activation. So take box over an objects line is the whenever the object is activated. So these processes show activation of this object. So the objects exist, but only during this process they're active. That's when the control is actually at them. So the single box by itself is activation, and if you have two boxes like this, it's called nesting. Basically, the object calls a function within itself, so it's a nested call. And that's how it's shown. Next slide. So we can do lots of complicated things with these sequence diagrams. Not that you have to do it, and I never actually use these types of diagrams, but if you need it, you can do it. So you can put loops and also like if statements. Those are called alternate boxes. So let's look at the loop. So loop means everything within this box is going to be repeated, and it says for each line item. So this is about some orders. For each line item, it's gonna do this thing, this part, which is an if statement. So it says if the value is more than 10,000, then do this part. I guess it's the dashed line is showing that part, and this is the else part. And otherwise, you do this part. So you either, if it's more than 10,000, you do a careful distributor, or otherwise you do the regular distributor. and you do it in the loop for each item. And finally, after you're done, there is an optional area where if it needs confirmation, then you call the confirmation messenger. Okay. So the optional is without an else statement, and alt is an alternate, like 1, 2, like if and else statement condition. Okay. Next slide is an example. Another storefront with a cart and inventory. There's a loop where you're in the storefront, you're on the website, you're adding stuff to your cart, you add item, return, add item, return, and whenever you're doing that in the cart system, the cart object is going to reserve the item from the inventory so that somebody else cannot buy it because you already marked it to be bought. And after you're done doing this in a loop, you go to checkout in the storefront, you click on checkout, which was go to the cart, you looks at all your items. So it calls a process order for the items in your cart, and then goes back to the front saying that confirm. If you confirm it, it will go back there and then place the item in order in the inventory. Okay, so it shows very nicely, and this is within a it's labeled as an example. You can put a label for a diagram like this. It's very nice description of some process, right? It shows you exactly what's happening over time, which functions are being called, and how they relate to each other. So they're very valuable. By looking at the diagram like this, you can also understand some things very quickly. For example, you look at this versus that. What do you see? What is the main difference between these two? This looks like more organized, and in here it looks like this function, this process is actually controlling everything. It's like calling this one and that one, this one and that one. However, in here it just calls one time the second one, and then it completely delivers the control to it, and then that guy calls another one, calls another one, calls another one. So they're more autonomous system. This is more nested autonomous system, whereas this one is more centralized. It's one controller decides on to do everything. So in general, we prefer these types of system, more nested systems, because they're better, they're robust. If you deliver responsibility to each submodule, and they call some other submodule, it's a little bit easier to maintain because then you have a general hierarchy, and you can reuse these components. As opposed to in here, if you have a main program that calls little functions in a sequence, then you never have like intermediate levels of generalization or intermediate levels of control of what's happening. You have to, each time you have to start over and call all these functions in order. And examples of these two are here. This is like central controller calls different functions, and as opposed to in here, like there's you switch the control to another program which calls another program, so it's a little bit more independent control. Next slide. Let's just wrap up. We've seen already the 3 types of diagrams, but I'm sure all of you are thinking, what's the point of all of these diagrams? I already told you a few times, you should be using these only when it's necessary, but you can be critical and saying, why not just put the code, right? As I said, it's much harder to write the code, it's harder to change it, and it's hard to communicate. So the diagrams makes it much easier for you. Sequence diagrams are very close to like coding level, but they're still a little bit above coding. So they can be implemented with different languages, so they are not limited to one language. It can be understood by non-coders like artists or business people or clients. You can look at as a team on the sequence diagrams, and you can see a lot of objects and classes on the same page, so it gives you a lot of visual bandwidth. Now, UML is often misused, so you should be wary about it. Now, there are some quotes in here. For example, says trouble comes when people feel compelled to convey the whole model through UML. You know, that's just too much. Then it gets too complete, or you leave too much out. You know, UML is not a programming language. You know, it's not supposed to take the place of programming. So don't try to do everything in UML. So again, UML, the second quote, UML tells you how to create and read well-formed models, but doesn't tell you how you should implement them. Okay, so you still need to go through the software development process to do that. So this diagrams will be the first step, but it's not gonna replace the actual development. So basically, the last quote is what I've been telling you. The UML is good for communication. Okay, so instead of just writing some text, it's much easier to write these diagrams, and it will actually save you a lot of time too. It will be faster. Okay. So with the UML, you deliver certain amount of precision, but you don't get lost in the details. Okay. Okay, so this is the end. As summary, UML is good, but it can be used effectively or it can be used horribly, like anything else, right? Flown's law says that good programs can be written in any language, and bad programs can be written in any language. It's all up to you. The operator decides. Now, UML is really good to know. It's a basic. It's very commonly used among software developers, and it does show up in interviews. So you should probably get yourself familiar with this language with these diagrams, and I'm sure it will be very useful for your project. So please give it a try. So we're at the end of the lecture. Please go ahead, go back to back to the survey that you filled in Blackboard and add this exit part. And if you do this, I'll give you the full points. And thank you for listening. And next class will be on version control systems, hopefully. And I'll see you in class. Bye.